Good day, everyone. My name is Ivy Davia from PICA 06402A, your reporter for this day. And for today's topic, we will discuss about Precambrian era. The Precambrian era. The Precambrian color red in the timeline figure is an informal unit of geologic time subdivided into three aeons: Hadean, Archean, Proterozoic of the geologic time scale. Aeon means indefinitely long period of time. Hadean. At this time, the earth was a very harsh environment. There was no solid crust, just molten lava covering the surface. All the water that we see in the oceans, lakes, rivers, and glaciers were evaporated in the atmosphere. Just imagine the humidity. The theory states that the impact caused a large amount of debris to be ejected from Earth, which later combined to form the Moon. Archean. As the earth cooled even more, the water in the atmosphere began to rain out. All the water that was evaporated in the atmosphere began to pour down onto the newly formed solid ground. By this aeon, in the Precambrian, most of the water had rained down from the atmosphere and covered Earth with a global ocean. Proterozoic. By the Proterozoic aeon, the earth had cooled even more, and the number of volcanoes had decreased from what was seen in the Archean aeon. Plate tectonics were still very active, and by this aeon, there were two supercontinents on either side of the planet. However, these continents look nothing like the ones we recognize today. Not only were they shaped differently, but they were completely void of life. Precambrian supercontinents. The movement of Earth's plates has caused the formation and breakup of continents over time, including occasionally formation of a supercontinent containing most or all of the landmass. The earliest known supercontinent was Valbara. It formed from protocontinents and was a supercontinent 3.636 billion years ago.
Pleasant morning, everyone. My name is Lyleric A. Apostol from PICA 06402A, and I will continue the report of Miss Ivy Rodavia. The Precambrian era. The land during the Precambrian era was a barren, lifeless, volcanic, and rocky landscape. The Earth was already more than 600 million years old when life began. The planet had cooled down from its original molten state, developing a solid crust and ocean created from water vapor in the atmosphere. Unfamiliar life forms. The first multicelled animals appeared in the fossil record almost 600 million years ago, known as the Diacarans. These bizarre creatures bore little resemblance to modern life forms. One of the examples of the Diacarans is the Dickinsonia, and according to my research, what happened to the mysterious Diacarans isn't clear. They could be the ancestors of later animals, or they may have been completely erased by extinction. Fossils and creatures. The first protozoa appeared, followed closely by worms. Soon after, arthropods, mollusks, and fungi showed up in the fossils record. Soft-bodied creatures like worms and jellyfish live in the world's oceans. The land remained barren. Common Precambrian fossils include mats of algae called stromatolites, microorganisms, and simple animals. As you can see, this is the example of the jacarans and fossil of Dickinsonia, and also the stromatolites or algal mats. Stromatolites is not only seen in the water but also in the rocks. Next, the earliest multicelled animals that survived the Precambrian fall into three main categories. First, sponges. Lacking organs or nervous system, they live by drawing water through their bodies and filtering out food particles. Second, Idarians, which included sea anemones, corals, and jellyfish, had sac-like bodies and a simple digestive system with a mouth but no anus. Third, annelids, or segmented flatworms, had fluid-filled body cavities and breath through their skin. Final stage. The final stages of the Cambrian time were marked by a prolonged global ice age. This may have led to widespread extinction, mirroring the black endings of the geologic periods that followed. Next is the compilation of the videos and the features at the time of the Cambrian.
The Earth, 3.4 billion years ago, and plate tectonics pushes the proto-continents together. They combine to form ever larger tracts of land. Scientists suggest that cratons combine with other cratons to form a supercontinent, a huge continuous stretch of land. It's called Valbara. Scientists are unsure of its exact shape or size, as only a few pieces, like the craton in South Africa, still remain. But Valbara's days are numbered. A rising plume of heat is growing beneath it. It's about to rip the world's first supercontinent into pieces. $2.7 billion years ago, Valbara, the world's first supercontinent, still dominates the planet. But plate tectonics, powered by heat from the Earth's core, is about to split it apart. Rock is a good insulator. When a continent gets very large, the rock traps heat beneath it. As it gets hotter and hotter, a plume of superheated magma builds up beneath the giant continental mass. The temperature continues to rise, and pressure in the mantle increases. Eventually, the crust can no longer contain the pressure, and the hot lava breaks through, ripping the land apart. You can see this process happening today in Africa. Heat from the Earth's core is ripping the continent apart. A giant rift valley runs from the Red Sea down to Mozambique. Giant cracks are opening up in the land. Volcanoes, like Kilimanjaro, mark spots where molten rock have risen to the surface in the past. In 10 million years, the eastern half of the continent will have split away. The molten lava trapped beneath the giant supercontinent of Valbara eventually smashes through the surface rock. The continent ruptures into several smaller pieces. These bits of land sail across the Earth. But nobody knows what happens to them or what the planet looks like at this time. The Earth is entering the Dark Ages. It is over 2.5 billion years since it was formed. It will be over 1 billion years before another supercontinent forms. The Earth is entering a deadly cycle of destruction and rebirth.
The theory of continental drift suggests that we go through cyclic phases of continental dispersion and then continental collision. And the continents then seem to move apart from one another and then collide with one another over a maybe 100 million year or more time scale.
When a large continent splits apart, the separate pieces travel away from each other, pushed by the creation of new land at the ridge between plates. Because the Earth has a constant surface area, the same amount of land created must be absorbed into the Earth. This process happens at subduction zones at the junctions of plates. At a subduction zone, crust dives down into the mantle to be melted to form new rock. When the plate subducts into the Earth, it brings two pieces of land together. When they collide, a new supercontinent starts to form. It is now 1.1 billion years ago on our timeline, and the next known supercontinent has formed. Its name is Rodinia, and it holds almost all of the continental rock on the surface of the Earth. Still, no one knows exactly what it looked like, but at its heart is an area that will eventually become North America. 350 million years later, the cycle of annihilation and creation starts again as the buildup of heat beneath the surface of the Earth tears Rodinia apart. When Rodinia splits, it forms several smaller continents that for millions of years drift apart and then drift back together again to form Gondwana, a supercontinent in the southern hemisphere. Eventually, after several 100 million years, Gondwana slowly splits apart. Plate tectonics pushed the land back together to create the world's last supercontinent. It's a huge landmass known as Pangaea. All the continents we know today are here, joined together.
never sees me, I'm losing every battle. No one ever sees